My name is Clayton Oakley-Robbins. This is my final for teaching engineering in the K through 8 classroom for Cambridge College. I'm just going to go briefly through my lesson plan based around one engineering standard of my choice. And so on this lesson plan here, I'm the only collaborator here, Clayton Oakley-Robbins. The summary of the lesson plan is that students will be able to grasp the concepts and knowledge and skills associated with the engineering technology standard 1-2, which states that students are able to generate several possible solutions to a given design problem, compare each solution based on how likely uh, they are to meet the criteria and the constraints of the design problem. And by doing this, students will be able to access this standard through notes that I will provide, a ticket in that they will have to complete, and an engineering challenge of making paper airplanes. And the reason that I'm giving for these students to make these paper airplanes is very similar to the Iditarod, where trains were no longer available to deliver life-saving medicine. We're applying that same concept, except we're thinking of other remote areas that would be more easily accessible via gliders, aka our paper airplanes. And so that is our problem. We have to try and deliver these things into remote areas. And so our paper airplanes are going to serve as the delivery vehicles. And so the goal is to create several paper airplane designs within the constraints of the task, compare each, and determine which will work the best for our criteria: distance traveled, and time afloat. Not enough distance traveled won't get the supplies to those in need, and too short of a time afloat will likely result in damaged supplies, aka moving too quickly. So a balance needs to be achieved for a successful trip, successful delivery. And so this is should be for a third grade level. The time frame is about 108 minutes or two 54-minute periods. It covers the subject of science and specifically engineering and design. And just like I had stated previously, it's a nice tie-in because around this time of their scholastic career, about third grade is where they learn about the Iditarod or so. So it's kind of fresh in their mind, the purpose of that. And so throughout this, students will be able to generate several ideas or solutions for a specific design problem, understand and articulate the criteria and constraints of a problem, and compare and evaluate each proposed solution against the established criteria and constraints. Um, and just some essential questions that we're going to be looking for and answering throughout this process. What are the steps of the engineer design process as a review? What forces are involved in flight? What limitations are involved with our engineering project, talking about the constraints? And then how are we going to evaluate our criteria? And then just some other skills that they will be learning. Will be, generating multiple solutions to a problem, comparing and evaluating, pros and cons, that sort of thing. Um, Problem solving strategies, recording data, those sort of activities. And then I've also provided some other links that we'll go through here. And so, how this is going to go, what their actual task is to create, design, and then actually construct these paper airplanes within the constraints of the challenge. Compare each of the designed and tested airplanes and determine the designs that best meet the criteria to solve our problem. And the students are going to record information. And as we scroll down, I'm just going to jump down to the sequence here. So students, how we're going to first start this off is with a review of the engineer design process. And so we'll go over slides that look like these, talking about this image that at this time we would have presented several times as an introductory. And then at each time we talk about the engineer design process, we'll review this. And we'll just go through these different steps, specifically those that involve our paper airplanes. And after our review, we'll actually introduce the newer material, the actual forces and those sort of things that are involved with our paper airplanes. So those look like this. And we will start off with a nice prompt at the beginning, an opportunity for a think, pair, share for students to talk about this question here. What types of things fly? And so we'll get a whole list of things that these students will know that fly, airplanes, helicopters, birds, um, insects, anything that has, the ability to, kind of defy what's, common to us. So we'll go over a list of things that fly, and then we'll talk a little bit about what we're going to be working on. I'll probably show them this video of a world record paper airplane fly, but then we'll ask another question that will, kind of leave a little bit more open-ended for the students, and we won't do think, pair, share, but um, just trying to explain and keep that inquisitive thought going about how do planes fly. And then we'll talk about the forces and the four forces of an airplane that we're focusing on mostly will include lift, weight, thrust, and drag. And so we'll have the students copying down these notes and providing a couple different videos, images, and then a nice recap toward the end. And then this is where students will be recording that information. So students will be recording their information on this airplane, paper airplane challenge, Take It In, where again we show the different forces, with a plane and then also our paper airplane. They'll be providing their written notes as they go through. And then toward the end, just as part of the assessment, in your own words, explain how an airplane or a paper airplane flies or takes off using all four of the terms that we had just learned, those new vocab words. So that'll be a quick little ticket in so that we can make sure that the students are actually understanding the new material that they're being provided here. And then moving on from that, we will be moving toward the actual performance task, which is the design process. And so the design process ends up on a sheet like this, um, where the students are tasked to please draw their paper airplane design that you created for your engineering design challenge. You'll need to present your designs in order to receive your materials, paper, to bring your designs to life. They need to be done in pencil, neatly drawn, so please use a ruler. And then they need to provide two types of drawings, the side view and the bird's eye view, as well as a name, just to, kind of give them some ownership. And then toward the end, they're going to kind of repeat or reiterate their use of these vocab words, but specifically talk about their design and why they believe that this design will help us, deliver those medical supplies to where otherwise remote things could not go. And there's the reasoning. And then right down below, there's a scoring rubric for this, so they know exactly how they're being graded on this. So drawing, using rulers, drawing again with pencil, using rulers. And then your reasoning. Did you actually use those four words correctly in your response? And then a total of 8 points for that. And then once we have the designs all constructed, the designs all drawn out, students will then be able to construct, and they've already been provided lists and websites as reference for what they will be making, such as foldandfly.com, where they have a bunch of different designs, and they even tell you what these types of designs are key for. So we've already discussed that we are looking for something that can go a far distance and something that can stay in the air for fairly long. That way, we have the greatest chance of success for helping these people to deliver these medical supplies. So there's a whole list of different types, and when you click on certain ones, they'll show you how to actually draw, design, and fold them as well to get to where you need to be. And so after that, we will actually go out and then test. So this is usually the constructing and testing part is usually the second part of these two sessions. And we'll record our data on a chart like this that I'll be providing and probably have students help fill in as we go. So we'll keep plain numbers. We won't have student numbers just to, keep it not anonymous, uh, but to keep the information all in line here. And then we'll provide distances and time afloat. So we'll have students that are both measuring with measuring tapes, as well as stopwatches to see how long these things stay in the air and how far they go, so we can find the perfect balance to meet our criteria. And so we'll look at this list again toward the end to try and pick out the ones that are meeting those two criteria: longest distance and furthest time in the air. And then toward the end, we'll have a discussion about what could have been done differently to change our results. And so again, this type of project is something very simple, but can hit a lot of different things that we're trying to do here, including some physics as well. And simply just need pieces of paper and possibly some scissors for what we're working with. We're not using tape or glue or anything like that. It's all just folding paper. So then students can make paper airplanes just like this, or any other type of design that they are thinking of. And then just some differentiation for students that have a little bit of trouble, or just with some of these concepts, just opportunities for handwritten notes or typed to be accessible for students with speech to text technology requirements. We will have models presented like I just showed. Use of digital platforms in case drawing is an issue or it's not possible. They'll be able to design on the computer if they need to. And also with a lot of English language learners, obviously translation dictionaries and or the use of translators, digital or otherwise, will be provided. And then for students that are a little bit more advanced, there's going to be opportunities for them to create more than one plane, assist others, give them roles of like a captain to go help out other people that are just having a little bit hard time constructing. And then also to provide a little bit more challenging designs. And then just down below, here's some resources that we're going to be needing. You have your supplies, very simple, just the printer paper, 8.5 by 11. And then some scissors potentially, and then just some attachments that I've created as well. Um, Lots of different things that will probably be printed, but also digital as well for students for accessibility purposes, and then web links to different parts of what we're looking at. So, story of Iditarod, in case that's a nice refresher. YouTube videos to show them how to create these things or the concepts behind flight, and then other websites where they can kind of go at their own pace to fold and do what they need to do. So there you go. There's a nice, quick uh, engineering design